Hello everyone and welcome to Microtrac's free webinar introducing the Microtrac Sync, our new hybrid laser diffraction and dynamic image particle analyzer. If you have any questions during the presentation, please type them into the question box in the control panel and we'll be happy to answer your questions at the end. A recorded version of this webinar will be available on our website, microtrac.com. Your speaker today is Terry Stauffer. Terry works closely with Microtrac as a particle characterization specialist. He has over 50 years of experience in the industry. In today's presentation, we'll go over the concept of the sync and the technology behind it, the data available and how to read it, and finally we'll do a recap. At the end of the presentation, we'll be happy to answer all of your questions. And now, without further ado, I'll turn it over to Terry.
Thanks, Claudia, and welcome everyone to the first webinar on Microtrac's new Sync, the novel next-generation line of particle characterization instrumentation. The Sync line is a combination of two important particle characterization technologies, laser diffraction and dynamic image analysis. But why combine them? Well, for one, laser diffraction has been the most dominant particle characterization technology for decades now across all particulate processing industries and applications. It's the de facto standard for most. So both suppliers and users of particle-based systems use this same technology to verify size specifications of the materials they sell and use. And this isn't likely to change anytime soon. Laser diffraction is fast, easy, accurate, robust, and broadly relied on across all industries. One perfect example is the atomized metal powder suppliers and manufacturers of powder metallurgy parts from those powders. Laser diffraction for outgoing QC by the supplier and for incoming QC by the user. On the other hand, dynamic image analysis has rapidly become a much needed technology for quantifying multiple particle shapes, as well as many more size dimensions like length, width, area, perimeter. With the Sync, users can have the best of both worlds, the tried and true for continuity and the visionary to find new ways to improve product quality. Think of dynamic image analysis as a highly complementary technology to laser diffraction. So let's take a look at the major benefits of the Sync and Microtrac's approach in this new product. For the Sync, simultaneous measurement, the very same sample and user interface as opposed to two different analyzers and measurements on two different samples. An extended blend algorithm, 0.01 to 4,000 microns on one sample. And self-connecting sample dispersion modules for the fastest, easiest changeover from wet to dry sample delivery in the industry. For laser diffraction analysis, a unique non-spherical refractive index compensation which eliminates reporting false finds modes, modified Me theory for correct reporting of translucent particles, 3 diode lasers, optional red or blue laser wavelengths to optimize on different size ranges. The dynamic image analysis, 30 different size and shape parameters for detailed morphology on each individual particle. A view of every particle in the image file for fast qualitative analysis of the sample's morphology. A search feature which can be used to isolate different components or subpopulations in the sample. A filter function for automatically reporting or filtering out different subpopulations in the sample. And the ability to remeasure image video files to compare the effects of different SOPs without running a new sample. Here are photos of the Sync liquid dispersion module on the left, the optical bench and electronics, and the dry powder dispersion module on the right. The dispersion modules, each with its own sample cell and mounted on 4-ball bearings, can be interchanged within 10 seconds, with all tubing and electrical connections mating automatically. Some features and benefits of the FlowSync module for liquid sample dispersion: auto-filling, deaerating, pre-circulation, and circulation for consistent repeatability, an inline ultrasonic probe with variable power for optimum sample dispersion, selectable SOPs, just add sample, click, and run, ease of use and repeatability, separate fill pump for water or solvent source for versatility, an auto drain, rinse, and wash feature to eliminate sample carryover. Here's the TurboSync dry module. It features a turbulent flow system for full sample dispersion. Adjustable airflow provides flexibility for free-flowing to tightly agglomerated samples. It handles samples as small as 0.1 cc for expensive materials for cost effectiveness. Measurement time is typically 10 seconds for high productivity. Selectable SOPs again, ease of use, repeatability, and the quick one-step connect-disconnect feature for ease of use. These are a couple of frame shots from a short video on our website, microtrac.com, of the inner workings of the FlowSync and the TurboSync. Under the FlowSync, you can see the sample cell and flow back past the ultrasonic probe and below into the sample chamber and pump. The TurboSync shots show the sample tray, upper left, and the airflow system, and below that, the turbulence dispersion area above the sensing zone. Here's a top-down view of the Sync's hardware integration. One bench, one sample, one flow path, one sample cell, one measurement, one user interface, 2 analyses, 2 complete sets of data. Clockwise from the top, the laser diffraction hardware includes the 3 lasers with options of red or blue wavelength for highest accuracies at different ranges, and 2 diode detector arrays on the right, measuring scattered light from 0 to 165 degrees. The sample cells, one mounted in each dispersion module, are located where the white arrow points. And the dynamic image analysis hardware includes the high-speed LED strobe at top and the optics and digital camera assembly in the lower left. The Sync uses a unique blend algorithm to calculate a size distribution which seamlessly combines the results of both the laser diffraction and image analysis technologies in the size range where they overlap. And again, it can provide a size range from 0.01 up to 4,000 microns. A few slides here on the laser diffraction data from the Sync. Callout 1 here shows the various tabs for the overall Sync software data. Summary data, tabular data, raw data, Setzero calibration data, and the tab on the right for size and shape for access to the image analysis post-measurement software. Below that row, callout 2, is the laser diffraction data in this display view. The list of summary data, percentiles, size percent, peak summary, and below that the size distribution graph. To the right is a list of more features accessible. Recall, validate, export, and print data. Set up pass-fail tolerances. Create trend charts and custom reports, and compliance with 21 CFR 11. These are views of the laser diffraction tabular distribution data on the left, the raw data on the detectors, and at the right, Setzero calibration data. This is the set of parameters Microtrac reports for the sync image analysis data. Rather than go into each in any detail here, I'll describe in 4 general terms what they measure. First, of course, is size. We give you 12 different size measurements of each particle in various diameters, lengths, and more. The last 3 columns are shapes of different natures and are generally expressed as ratios of size parameters. Form factors include 10 different parameters that indicate how closely the particle is to being a perfect sphere, or various aspect ratios or elongations of the particle. Surface smoothness parameters are just that. 3 different parameters can indicate the texture of the particle surface. On a scale of 0 to 1, convexity and solidity values of 1 are particles with a completely smooth convex surface. Concavity would report the reverse. 2 other parameters report the overall light intensity coming through the particle, transparency, and the curvature of the particle as a gradient of light intensity. Interim size parameters are used to calculate a number of shapes. But don't be overwhelmed. Only a few parameters are used for any one application. This slide shows the size shape data tab, callout 1, which displays some image analysis data, as well as some selections for accessing more screens of image analysis information. The size distribution graph and tabular data are shown to the right. Callout 2 points to the summary data reported in this measurement. A selection box where further image analysis information can be chosen is shown in callout 3, View Particles. Those screens will be covered in the next 2 slides. This is the particle viewer display in the Sync software. At top left is one camera frame from the saved video file. The lower left window is the complete scrollable image file. The text list in the upper right is a list of all parameter values for the image selected in the blue box in the frame and in the image file. The red vertical arrows indicate scrollable windows and window size adjustment. Selection of the Search Particles box, callout 1, opens the particle query window shown overlaying the frame. A search for images less than 70 microns in area equivalent diameter, or DA, and less than a sphericity of 0.96 has been created and is listed to the right of the Search Particles selection box highlighted in blue. A sphericity of 1 is a perfect sphere. When this search is selected, the image file then contains images of only the particles which fit into the search region. Any number of parameters can be entered into one search, and any number of searches can be created for one sample analysis. Callout 2 shows an area of selectable choices specific to the displayed image file. At the left is where the displayed parameter value is chosen. sphericity in this case. The next two boxes show ascending or descending order. The parameter value can be displayed, and the image size scaling can be changed. Callout 3 points to the scatter diagram selection box. The next slide shows and explains this feature. The scatter diagram is another useful feature in addition to the search feature for identifying and isolating different groups of particle types. The scatter diagram itself is the area in blue. Each blue square shows where every particle in the sample is located relative to the x-axis distribution in the top horizontal graph and the y-axis graph to the right. Here the dA size is shown in the top graph and the sphericity shape parameter on the right. Darker blue areas are regions of high concentration. Percentile sizes are listed to the right for both dA and sphericity. This sample is a glass bead size standard and shows its main mode centered around 70 microns. There's also a very small fines mode at 40 microns and a larger region above 80, which is made up of fused glass beads. Examples of the images in each mode were copied from the image file and are displayed at each mode in the scatter diagram. The X and Y graphs are shown in volume % format. This infinite resolution is possible because every separate particle in a sample is measured individually by image analysis. Each particle has its own signature of all the parameters. This is the level of resolution needed to detect very small amounts of contaminants or out-of-spec material in a particulate sample. Here's a list of the current largest specific applications known to require laser diffraction and dynamic image analysis technologies to measure their quality. Metal powders referred to earlier require high flowability and packing density for even, fast loading and high strength for final parts. Key parameters to spec are sphericity, smoothness, and size. Next, propants, which are sand or ceramic particles which keep fissures in hydraulically fractured shale oil or gas deposits propped open. The fissures need to allow high conductivity or flow rate to the surface. Key parameters, as specified in American Petroleum Institute and ISO standards, include Crumbine slot sphericity and roundness, as well as size. Granular fertilizer needs to flow well for even spreading and then evenly release chemicals into the soil. Key quality parameters are sphericity, smoothness, and a very narrow size distribution. Reflective glass beads used in highway safety coatings have to be highly reflective, be skid-proof by containing a proportion of added sand, and have a narrow size range. Key quality parameters are sphericity, smoothness, transparency, and narrow size distribution. Drug time release capsules need to have controlled, even drug release properties. Key parameters: sphericity, smoothness, and size. Extrusions made by granulation need to be of consistent length, diameter, and perimeter. Key parameters are aspect ratio, smoothness, and size. Abrasives used to clean, polish, or abrade hard surfaces need a spiky, sharp-edged external surface and various size distributions for different tasks. Key parameters are the Crumbine roundness and size distribution. The lower the Crumbine roundness, the more sharp-angled the surface is. The previous slide focused on specific applications known to require size and shape measurements. But generically, all applications of particulate systems share the same problems, which can be readily identified and quantified by a combination of size and shape properties. The most common one is agglomeration, and the presence-absence amount of agglomeration might be good or bad for different applications. In most processes, it's an undesired feature. And size alone can't detect the degree of these first three generic problems, but parameters like smoothness, aspect ratio, and transparency can. Contamination from the process, sample handling, and packaging can be serious problems for product quality. It may be in the form of oil droplets or shards of metal, glass, or plastic, but it can be detected and quantified by shape parameters. Too much sample debris in the form of broken glass beads, metal powders, time capsules cause quality problems. The debris can be isolated and quantified with shape parameters. Oversized particles in very small numbers can cause problems in processes like compacting, sintering, pelletizing, and granulation. But because every individual particle is measured in image analysis, it can detect and report the presence of even a single particle in a chosen size range. Only this particle counting type of technology can do that. And total particle count is always reported in a sync analysis. In summary, the Microtrac Sync is the next generation of particle characterization technologies, combining simultaneous laser diffraction and dynamic image analysis. It offers a continuous blended size range from 0.01 to 4,000 microns. Laser diffraction is the de facto standard in most industries, and dynamic image analysis is rapidly growing in use as applications learn to use shape information to better control quality. Two different sample dispersion modules with rapid automatic connections provide adjustable settings for any level of desired dispersion. 3 options for laser diffraction wavelength combinations to optimize user-specific ranges. And with that, Claudia, I'll turn it back over to you for questions and answers and wrap up.
Thank you, Terry. Okay, we have a couple questions here. What is the range of laser diffraction particle sizing, wet and dry?
I'd like to refer you to the product brochure on our website, microtrac.com. There are a number of different models of the sync. They vary in ranges, they vary in the combination of lasers, and they vary in whether they're wet or dry modules or both. So you can look up all that different information on the website. I don't have a table in front of me.
Yeah, we also have the brochure as a handout in the control panel on the right-hand side of your screen, which will specify the ranges for wet and dry. So someone wants to know how little solvent can be used with the FlowSync.
Water or any of the common solvents that are used in wet particle size analysis can be used in the sync. It's fine for both laser diffraction and for dynamic image analysis.
Okay, do you have the correlation between sphericity and tap density or flow rate?
Well, we don't have that kind of information, but that's the kind of information that customers develop. They make the measurements on the powder and compare that to the tap densities or flow rates or whatever properties they're measuring for the metal powders or for the powdered metallurgy parts.
Okay, thanks, Terry. And someone would like to know, is the dynamic image analysis a photo of the particle or of the particle's shadow?
It's a photo of the particle. A strobe light backlights the particles, and the camera is on the other side of the flow stream. So we get outlines of the particles, and if the particles have any translucence, you can measure the amount of light coming through the particles, and that's often a very desirable parameter to look at.
Okay, and does the diffraction comply with ISO 13320?
Yes, it does. That's for laser diffraction. Mm-hmm.
Okay, and does it also comply with imaging 13322-?
And yes, it certainly does for that too.
Okay, great. Let's see what else we have here. Are there validation IQ, OQ packages for both?
Yes, there are.
Awesome. What is the total measuring time for both analysis?
I would say that 90% of analyses can be completed very easily in less than 10 minutes, often less than 5 minutes.
Okay, and what is the smallest volume of liquid that can be used?
That was 0.1 cc, or I'm sorry, that was for the dry. The smallest volume of liquid, I would have to refer you to someone who has that information handy. I don't, but Claudia's email address is here on this slide, and you can send any questions that that you have right now or you might come up with later to her, and we will get back to you.
Yeah, absolutely. If there are any further questions after the webinar, please feel free to email me at claudia.gaitan@microtrac.com, or you can always respond to the recording that I'll be sending out of the webinar for future reference. And as always, you could submit a form through our website. Someone asked about how you can get a demo or arrange for a demonstration. Like I said, either contact me directly or go through our website and fill out the form so we have all your information and can set that up quickly. Oh, and we got a couple more questions actually that just came in. So, okay, what is the size range for the image analysis measurement? What about focal plane issues?
The size range varies depending on the model. There's a model range from 5 to 2,000 microns and from 50 to 2,800 microns for the image analysis size. That's for wet. For dry, it goes up to 4,000 on the dry. And the image plane, the focal length, there's an automatic algorithm in the software that captures only particles that are in sharp focus right on the focal plane.
Great. Oh, and so our applications director has chimed in with an answer to the question about the volume of liquid that can be used, and it's 200 ml. So
I'll write that down.
There we go. Now we know. Okay, I'm not sure that there are any more questions. Feel free to shoot us an email if there are. And thank you very much once again for attending, and we hope to see you guys at our next webinar.